Hi, everyone. Thanks for coming. My name is, as you mentioned, James Saryerwinnie. I am a software development engineer with Amazon Web Services, AWS. And today, we're going to look at how to support everything. And yes, by everything, I mean Python2, 3, Windows, Linux, Mac. Specifically, we're going to look at 2.6, 2.7, and 3.3. And the idea is that the techniques and the patterns that we look at can extrapolate into other platforms and into other Python versions. So yeah, support almost everything. So the context here is, let's say I have a library and I want to open source it and I put it on GitHub. And I get my first bug request, my first issue that someone says that it doesn't work for me. And if you look at what platforms versus Python versions your library might support, you might have something like this, which is the works for me version. And if you work on it, you might be able to get something like this, which is what a lot of libraries are at. So you don't support Python 3, but Windows or Linux and Mac fairly similar, and so you work for 2.6 and 2.7, and Windows maybe. You haven't really tried it. But if you look at a lot of popular Python projects, Request supports all of these. Jinja 2, Simple JSON, Django. That's not to say they got popular because they supported all these platforms, but it might even be just as users, as it got more popular, people wanted to port their platform of choice onto into the project. So if you really, I think what's important here is that having a plan for how to support multiple platforms and how to support multiple Python versions is going to be a good thing going forward. Even if you don't do it immediately, at least have a game plan for your project. So the gist of this talk is really just find what varies and encapsulate it. Just general design advice, good advice to follow. The trick is actually finding what varies and seeing how existing projects encapsulate it. And so this is more of a what do existing projects do rather than what may be the best way to do it. I mean, most of them follow best practices. So we're just going to look at platforms and then Python versions, and we're going to start with some of the differences between these two axes here. So with platforms, you're really looking at interface differences. So this is just maybe the actual arguments or things changed. And then there's more of the behavioral or semantic differences across platforms. And we're just going to look at a few of them to get a feel for, these are some of the ones that I've run into in practice. But it really depends on your project and what your applications or what your library is doing, because a lot of these really are dependent on what area you're really working in. So with interface differences, sometimes it's as simple as this. So mmap, which is fairly low level, but it's in the standard library. You just have different arguments depending on if you're on the Windows version or if you're on the Unix version. And so you can't use those three arguments if you want to be cross-platform. You also have things like at the module level, you just have different constants. You don't really use these constants that directly unless you're dealing with os.open. But you have different capabilities per platform. You might also have, so in the select module, in Linux you have epoll, on Mac you have, or BSD variants, you have KQ, and then Windows, you can fall back to select, but you don't really have anything. And you also see things like this, where there's an argument and you can pass it, but it doesn't actually work on Windows. So that's another thing you have to watch out for. And then sometimes just you don't have modules available. So if you're writing a command line application, and maybe you want to put a nicer UI on top of it, you don't have curses available, at least in the standard library. There are third-party packages you can install, but you don't have this available to you in Windows. So in terms of sort of the more behavioral differences, you have an example would be something like this. So I open a file, and then I remove it, but I still have a reference to that opened file object, which works in Linux and Mac. And you would think, why would you do this? But it tends to leak into higher-level libraries. So an example of where you might run into this is the logging module. So say you have a file handler, and maybe in your test cleanup or part of your application, you just want to delete the file. But then it won't work with the logging handler. You have to track down the file handler that's attached to the logger, and then close that file, and then you can delete the file because, well, this works in Linux and Mac. On Windows, again, you can't delete a file because the process is using it. Same thing, and I'm picking on files just because I think that's a very intuitive concept that we all understand. But with files, temporary files, you can't open the same temporary file. In Windows, you can argue it actually has a better security model, but regardless, there are differences between how temporary files work. And then also, this is one that I've run into before, which is very common in your application. If you have application data file and you want to write a new version, You write it to a new temporary file, flush it, fsync it, and then do the atomic rename on top of the old one, which works fine on Linux and Mac, but again, not on Windows. So with Python 2 and 3, some of the differences, I'm not going to go into a whole lot of it just because there's really good resources, and there'll be links at the end if you're interested in more of the details. But in practice, these are the ones that I've run into, which is module renames. Just things have moved in Python 2 or in Python 3 versus Python 2. And then you have API differences. So in this case, the iteration protocol is a little bit different. Just in this case, it's just method renames. And then syntax stuff. So if you're supporting only Python 3.3, you won't have to deal with this specific one since Unicode literals are back. But might have to deal with some syntax problems. And then finally, this is probably the one that I've spent the most amount of basically strings versus bytes or Unicode in Python 3. And I would just say plan to spend some time on this. Again, it's dependent on what your library is doing. But in general, this is probably the thing that I've spent the most amount of time in supporting Python 3. So these are some of the differences. How do we deal with this? I would say using a single code base. There's been a lot of different strategies, the 2 to 3 versus this, and I would say maintenance-wise, a single code base is the easiest way to do this, and it's especially if you support just that subset 2.6, 2.7, 3.3 in those 3 platforms, it's definitely doable. For Python 2 versus Python 3, you can use 6, which is just a module that encapsulates a lot of those differences. And you have a few options for you. You can add it as a dependency, which might have problems if your package and other packages depend on different versions. You can vendor it, which I believe is the approach Django takes. Or you can have a basically do-it-yourself module. I mean, there's not a whole lot. If you look at what 6 is doing, it's not actually that much. So you can just have your own version and pull in the specific parts that 6 has. And a lot of projects, what they do is they just have a compat.py. So an example of this is from a project I work on. You just have, if you're in one version of Python, you import things from one location versus another. And here's an example from Jinja. So this one's _compat, but similar. This is glossing over the differences between the iteration protocol renames. So in the Python 2 version, you can see there's a class decorator that just renames it for you. And in practice, that's usually sufficient to just have a single module that hides all the differences, and you refer to that compat module. And for 2.6, 2.7, 3.3, you'll be fine. For platform differences, there's a few ways that existing code handles this. This is from the subprocess module in the standard library, so if you want to run processes. Basically, you have a module level variable that tells you what platform you're on, and you just put conditionals everywhere. So in this case, if you're in Windows, tell them that they can't use an argument. Otherwise, you're in POSIX land and do anything else. And while this works, one of the problems with this approach is that it tends to sort of bleed into everything else. And if you actually look at the code for subprocess, 60 lines later, there's for also in Windows, here's more stuff to do. And this is at the method level, and then there's also at the class level. So when we're defining a class, if we're in Windows, define these set of methods. Otherwise, define this other set of methods. And so it gets hard to figure out what version you're looking at. And then similar for module level constants as well. So another approach that other projects have taken is doing it at the module level. So this is closer to the compat module, the compat approach for Python 2 and 3, which is where you just put things in, you have a POSIX module, Windows module, and then any other platforms you support. And then in your util module, you just figure out what platform you're on, import it, and then those are where all the differences stay. You also see this in the standard library in the OS module. If we're in POSIX, then do the wildcard import from POSIX, otherwise NT. And you always refer to the module. The module you use is always OS, os.path, os.get current working directory. You never use the POSIX or the NT module directly. And again, just another example, Tornado does something similar. They actually have a platform package in their code, and then, again, detect what platform you're on and import the appropriate classes. But you can kind of see in this last example that there's this from Tornado platform common import Waker, and it's basically saying that if we're on Windows, just use a common implementation of that, which kind of sounds like inheritance and kind of sounds like subclassing, which is why I think another approach is this factory-based approach where you just have your dependencies. Instead of modules, you have them as classes that you have these factory functions create. And that gives you a little bit more flexibility, specifically for platforms. And this is an example from a project I work on, which is basically a key value storage in Python. But the point here is that it takes a object that renames things, and it takes a loader that loads things, and then based on certain platforms or whatnot, it will actually use the right version. So an example of this in code is something like this, where if you're on Windows, then use the Windows renamer. If you're on, this is actually something we don't get to look at, alternate Python VMs. So there's CPython versus PyPy versus Jython. In this case, Jython doesn't have a particular module, so we're going to use a simple file-based loader. Otherwise, we're going to use a little more efficient loader. And then you just return the actual object you're creating based on the renamer here, or sorry, based on the parameters here. And the reason that this is nice is because it allows you to write additional, you're basically not tied to a particular implementation. Because the differences between Python 2 and 3, they're pretty much set. Whereas with platform, you can imagine, maybe you have an initial Windows version, or you have some kind of default version, but maybe you have another third-party version that's based on the Win32 API that, or you have something based on C types that loads the appropriate DLLs, and it's much closer matched to maybe what the POSIX one exposes by default. And so you want to be able to use that implementation versus using a basically least common denominator where you don't use some of the features. So that's why I think that using a class-based approach for platforms is going to give you a little bit more flexibility to support the different platforms. And finally, testing. I could say a lot about this, but I think it's just, yes, please test everything. The problem, so one of the things you'll find is that even though in theory everything should work, so, oh, sorry about that. Everything should work. You'll find that differences between Python versions might have bugs. So while the docs say everything works, maybe when you actually run your tests on Python 2.6, something actually fails, and you'll have to work around that. And the only way you can really find that is by testing everything. So for Windows, Jenkins is a great system to use, very easy to set up, and then you can have identical systems for Linux and Windows. But I think in general, just you should be testing all of this. And there's more information here that will be online that just goes into more detail about supporting different Python versions and different platforms. And that is all I have. Thanks.
So it looks like we've got time for perhaps just a couple questions. If you just mentioned something a lot earlier in your talk about taking a vendor approach to the 6 library. Could you just, as opposed to just packaging up it with your own, you said Django does something like that. Could you just elaborate what that would mean a little bit? I'm not familiar with it.
So basically, so the problem with having 6 as a dependency is that if you have a strict dependency on a particular version of 6, and then so you have another library that depends on a different version of 6, and you'll have a problem when you try to install it saying, there's conflicting versions here. And so an approach that, and I believe this Django has this Django util 6 or something like that, which is just to have that included in your code base, just to have the actual, 6 is just a single module, and so just have that in your code base, and then in addition to that, it also has further customizations that it adds on that are specific to Django's code base, and so then that way, since it's a single module, you don't run into those problems with what if you have different versions for 6. Yeah.
In one slide, you described splitting up the platform differences into their own modules. How would that look from the caller's point of view?
Yeah, so the caller's point of view, what they would do is there's usually a single module where you figure out what platform you're on and import that equivalent version. So you say, like, if you're on Windows, import Windows as platform, otherwise import POSIX as platform, and then say that's in the case of Mercurial in a util module. So then in that case, all of your code references that single util module. So you'd have from your code.util import whatever you want. And so you're never importing that platform-specific class directly. Another example would be the OS. So if you've used the OS module, you might have something like os.path.split, but you would never say POSIX path.split. So if you use whatever that module is that figures out the platform and imports that difference, always all your code would reference just that module.
You mentioned that testing is kind of important. And
A little bit.
although that's easier said than done. And so I'm wondering if you have any ideas for like open source projects to have access to virtual machines or real machines that run different operating systems. My specific challenge is Mac OS. I don't have access to any Mac machines, but I'm sure a lot of people don't have access maybe, or legal access anyways, to Windows machines.
Yeah, so in terms of the open source one, I mean, the only one I think that we all use is Travis, and which doesn't support, like you mentioned, a Mac and Windows. As terms of open source options, I actually don't know, even not open source, there's not a whole lot of options for Mac, which is unfortunate. It is a BSD variant, so if you do have access to a free BSD machine, you will get most of the way there. Again, it really depends on what your platform's doing, but that might be another option, is to just use a free BSD version to test Mac. Yeah.
Small Mac Mini server.
Cool.
For really cheap.
Just so everyone can hear.
So for Mac, I think there are some like host provider that you can rent a Mac Mini where you can run your tests. It's kind of slow, but at least.
Is that all for questions? Okay. Let's give another big hand to James.